Dear students, welcome to the class. In the class, we are going to discuss one problem in eigenvalue, eigenvector. See the problem. Find the eigenvalue and eigenvector of the matrix A equal to 2 minus 2 2 1 1 1 1 3 minus 1. The 3 matrix is 3 by 3 square matrix, and then it is a non-symmetric matrix. So we can find the solution for this. To find the eigenvalue and eigenvector, first we have to write the characteristic equation. So first we write the one ready to find eigenvalue. The characteristic equation is A minus lambda I equal to 0. So for the 3 by 3 square matrix, what is determinant of A minus lambda I? Lambda cube minus A1 lambda square plus A2 lambda minus A3 equal to 0. So what is A1? A1 is sum of diagonal elements of A. A1 is sum of diagonal elements of A. So what is the sum of diagonal elements of A? We can add that 2 1 minus 1. 1 1 get cancelled. 2. A2 is sum of minus of diagonal elements of A. So how to write the minus for the diagonal elements? That is equal to, see that first diagonal element is 2, leave the respective column and the respective row, find the determinant of this one. So that means 1 1 3 minus 1 plus second diagonal element is 1, leave the respective row, respective column, 2 to 1 minus 1 plus third one is minus 1 is the diagonal element, leave the respective column, respective row, remaining element is 2 minus 2 1 1. Calculate this, that is equal to minus 1 minus 3 plus minus 2 minus 2 plus 2 plus 2. So what do you get? 2 plus 2 is 4. This minus 4, the 2 get cancelled. Then minus 1 minus 3 minus 4. Minus 4. Next A3. What is A3? A3 is determinant of A, that is equal to first element 2 into minus 1 minus 3. So here you have to, already minus is there, so you have to put minus here, that means plus minus plus now. So minus minus plus 2 plus 2 into minus 1 minus 1 plus 2 into last one 3 minus 1. So that is equal to 2 into minus 4 minus 8 minus 2 plus 2 minus 4. 3 minus 1 is 2, 2 into plus 4. So 4 get cancelled, minus 8. After finding that A1, A2, A3, you substitute the values in characteristic equation of A. So what you get? So I am doing that step by step. Likewise, you have to do that with me. The characteristic equation is lambda cube minus A1 lambda square. A1 is what here? 2 lambda square Then minus 4 is there. Minus 4 plus a2. So minus 4 lambda. Minus 4 lambda. Finally, minus a3 is there. Minus a3 means already minus 8. So here minus 8, minus is there. Therefore, plus 8 equal to 0. Next, we have to solve this. We have to solve this. How to solve this one? By synthetic division method. For the synthetic division method, you have to write that 1 minus 2 minus 4 plus 8. In the last class, I clearly explained how to find that the root of the cubic equation through synthetic division method. If you are taking this coefficient is a, b, c, d. A, B, C, D. If a plus b plus c plus d equal to 0, then the root is 1. Add this, all are not equal to 0. In case if you are adding that alternate element a plus c equal to b plus d, then root is minus 1. Root is minus 1. Add that minus 2 plus 6 and minus 3. It is not satisfying. So both the roots are not possible. Then we move to that plus 2. If you are substituting 2 here, arbitrarily put 0, add this 1 and 0, 1, multiply this 2 and 1, 2, minus 2 plus 2, 0. Now multiply this 2 and 0, 0, minus 4, add this minus 4 and then 2 minus 4 minus 8. Therefore, one of the root is plus 2. Finally, if you are getting that is equal to 0, one of the root is plus 2. Therefore, lambda equal to 2, one root. Then you have to write that it is lambda square minus 4 equal to 0. It is a coefficient of lambda square, it is a coefficient of lambda, it is a constant. Therefore, lambda square minus 4 equal to 0. Therefore, lambda square equal to 4, lambda equal to plus or minus 2. Therefore, the eigenvalues are 2, minus 2. Here you can note down one thing, minus 2 is okay, but 2, 2, the eigenvalues are repeated. So based on this we can find the eigenvectors. Write the heading to find eigenvectors. To find eigenvectors, first we take the distinct value minus 2. Take that minus 2 and lambda equal to minus 2. So to find the eigenvector, first we have to write the system of equation a minus lambda I x equal to 0. So how to write that a minus lambda into x equal to 0? In this given problem, we have to write that 2 minus lambda minus 2 plus 2, 1 minus lambda 1 and then 1 3 minus 1 minus lambda x1 x2 x3 equal to 0 0 0. So write the case 1. Case 1 is lambda equal to minus 2. Lambda equal to minus 2, then you can write here 2 minus of minus 2 is 4. 4 minus 2, 2. 1. 1 minus of minus 2, 3. 1. Then 1, 3. Minus 1, minus 2 plus 2. So 1 here. x1, x2, x3 equal to 0, 0, 0. To find the eigenvector, take any two identical, non-identical rows. If both of them are identical, no need to take any two non-identical rows. So x1, x2, x3, x1, x2. Write continuously 5 columns. So here 4 minus 2, 2, 4 minus 2, 1, 3, 1, 1, 3. So what is x1 here? x1 is leave the respective row. That is x1, 4, 1. Leave the respective column. You find the determinant of next two columns. That means minus 2, minus 6, minus 8. x2. x2 is leave the respective column, the determinant of next two columns. That means 2, minus 4, minus 2. This is x2. x3 is leave the respective column, determinant of next two columns. That is 4 into 3, 12 plus 2, 14. So what is the ratio? Minus 8, minus 2, 14. That is the eigenvector. If you are cancel that with minus 2, then you will get that 4, minus 4, minus 1, 7. That is one of the eigenvector x1 is minus 4, minus 1, 7. It is one eigenvector. Next we have to find the eigenvector based on this lambda equal to 2. What are the eigenvalues of the matrix? Eigenvalues are minus 2, 2, 2. So here we are finding that the eigenvector minus 4, 1, minus 4, minus 1, 7 is the eigenvector for lambda equal to minus 2. Next case is repeated case, lambda equal to 2, 2. At the time, how can we find that? Now, take the case 2, lambda equal to 2. Even that case 3 also lambda equal to 2, na? So, case 2 and case 3. Case 2 and case 3, lambda equal to 2. Substituting lambda equal to 2 here, 2 minus 2, 0. 0 minus 2, 2. 0 minus 2, 2. 1 plus 2. So that means 1 minus 2, minus 1. 1 minus 1, 1. Third one is 1, 3. 1, 3. Minus 1, minus 2. Minus 3. 1, 3. Minus 3. x1, x2, x3 equal to 0, 0, 0. Okay. Listen, if all the rows are identical rows, then for that repeated eigenvalue, the eigenvectors are linearly independent. If all the, please make note down that if it is a repeated eigenvalue, if we are substituting that lambda equal to 2 here, in case if all the rows are identical rows, then the eigenvectors are linearly independent. In case if it is not identical, how to find the eigenvector? x1, write that x1, x2, x3, x1, x2. So 0, 1, 0, minus 2, plus 2, 0, minus 2. Similarly here 1 minus 1, 1, 1, minus 1. So write here x1. To find x1, leave the x1 value, determinant of next two columns, that is minus 2 plus 2, 0. x2 by, leave the x2 column, so here 2. x3 is, leave the x3, then find the determinant of this 2 value, plus 2. So what is the eigenvector here? x2 equal to 0, 1, 1. It is eigenvector for one more lambda is there, lambda equal to 2. So x2 equal to, x3 equal to 0, 1, 1. In this case, when the eigenvalues are repeated, the eigenvectors are linearly dependent. So what is called the linearly independent? When you are substituting that eigenvalue in the system of equation, if all the rows are identical, then the eigenvectors are linearly independent. If the rows are not identical, then we can find the eigenvector. This type of eigenvector is linearly dependent. Okay, so therefore we can write one note here. The eigenvectors for the repeated eigenvalue may be linearly independent or linearly dependent. Okay, this is very important note. So when you are finding that the eigenvector for the repeated eigenvalue, it is very important. It is very important. You have to do very careful.